It's not even like walking around. You walk. You just like the same
This.
key and you place it with like well, because there's no alternate confusion basically. It's not
There's my
but yeah, that was I don't know.
this one. Make sure it's here. Okay. Do you want the camera on as well?
I don't think everything's
Yeah.
You kind of use. And then there's a flow in it. And then, yeah, how about they actually being for it's like you gotta see this. Oh, that's been it's good. I'm saying, no, we don't. See, I was wondering if we get another person to. I'm working as a board, so produces your order as to do.
Okay. Sure. Yeah, otherwise I might go through the design coordinate. Maybe. I'll see how I go. Yeah.
I think.
Should we get started? Yeah.
Both really, it's a nice.
Everyone, we're gonna get started.
Hello everyone, welcome to the Software Modeling and Design Revision Workshop. My name is Ashley and I'm a current tutor. I've been tutoring the subject for a few semesters. I think I started back in 2024. Yeah, so we have another presenter, Taryn, but unfortunately he's feeling unwell today, so he's not able to come. So I'll try my best to cover everything. Yeah, that's all. And then just a quick disclaimer, this workshop is not officially endorsed by the university or the teaching staff and may not fully reflect the accessible subject content. Any tutors that participate in this workshop have verbally chosen to do so voluntarily and then are not expected to represent the teaching team, okay? Yeah, and then about CSAR, do you want to say something maybe?
Hi, my name is Raphael. I'm the education director here, and yeah, we just wanted to talk about this workshop is held by CISA. We hold these every semester, and yeah, if you haven't joined already, we'll definitely give it a try at just joining us. Membership's completely free, and we will be hosting these again next semester if you're doing more concise subjects. Yeah, back to the workshop.
Okay, thank you. Another disclaimer, this is not an exhaustive guide. The single source of truth is the subject material. Yeah, we are volunteers, not being paid, not representing the subject officially, okay? Okay, so a quick agenda about today's revision workshop. So it's gonna take 2 hours and then we're gonna start off with the use case. And then we're gonna spend about 15 minutes on the 5 key diagrams that we are been practicing for this semester. And then we're gonna have like a 10 minutes break. After that, we're gonna spend some time to go through the design principles and patterns that we learned this semester as well. And then very lastly, we want to go through the architectural analysis. And then for the very last 10 minutes is the question and answer section, QA section. Okay. Any questions? All good? Okay. Let's get started with the part 1, use cases. So use case, it comes like in 3 different formats. We have a brief, casual, and fully addressed use case. So you should be pretty familiar with the use case text. So we've like have the different style here. So for the first one, it's the brief style use case where you just write one main success scenario regarding the questions given. And then secondly, we've got the casual style. So it's pretty similar to the brief style use case. You just add an alternative scenario, on top of the brief style. So you will, and then very lastly, we've got the fully dressed styled use case. So this one is quite long. So usually you won't like expected to see these type of use case in the exam because highly unlikely you're gonna have enough time. So your focus will be on practicing like the use case brief style and the casual style use case. Just make sure you are aware like the difference between these two. Okay. And then next we also have the use case diagram. So usually after you finish the use case text, you are expected to draw this use case diagram. So you should be pretty familiar with the diagram as well. So the use case diagram shows all the use cases in a subsystem and their relationships. And then each textual use case only describes like one use case. And then in the diagram, there's a few things you should be quite familiar with. So remember we have 3 different type of actors, and then you are expected to know all 3 type of actors. So we have a primary actor, supporting actor, sometimes we call it secondary actor as well. And then very lastly, we have the offstage actor. So on your left-hand side, this is where your primary actor, and then it's usually the end user of the system. So usually like customers, managers, staff members, those are the end users of the system that you're designing. And then on the right-hand side, you have your supporting actor and your offstage actor as well. So for supporting actor, it's usually like it can be a human, but it sometimes can be a system. So in this one, we've got an inventory management system. So this is probably the easiest one that you can come up with if you're required to write one, because usually no matter what system you design, it usually comes with like an inventory system. Yeah. And then lastly, you've got the offstage actor. Those actors that they don't really directly interact with the system. However, they influence the system. So the simplest example will be the government agency or the test agency. Like obviously the system you design need to follow those guidelines, but they are not expected to interact with your system. So that's the offstage actor. So you should be quite familiar with these 3 type of actors, and then should be able to identify and then draw those actors as well. And then in the big box here, you've got each circle that's representing like one use case, and it's usually quite high level. You can think it as like feature level rather than like in tiny details. So for example, you're not thinking about we are clicking into like a button, so it's too detailed. So instead, we're looking for like feature level. You search product, you view product. It's a very big feature. Okay. And then we also have the notation of include and extend up there. So what that means is, so for include, that represents the mandatory behavior. So for example, if you do checkout cart or buy now, no matter which one you go with, you need to go through the shipping and payment. It's mandatory, right? You can't skip that step. So this is when we use include, so that we don't have to, draw this shipping and payment circle twice. And then up here, we also have the extend relationship as well. So with this one, it's the optional behavior. So for example, when customers search for products, they don't necessarily need to go through the advanced search. For example, like applying a filter, like you want size 8, but that's not necessary. So that's something optional. Customer can choose to do that or not. So this is where you have extend relationship. Yeah, that's it. I think about the use case diagram. Any questions for that? Any questions? We all understand? Happy? Okay. I'm just gonna go ahead. Yeah, so this is just what we explained. So include is the subcases always execute, so you can simply remember as mandatory. And then with extend, it just adds optional behavior. It's executed only under certain conditions, so it should be pretty straightforward. Yeah. And then with this, you use the dash line to represent the relationship. Yeah, that's it for the use case. And then we just wanted to do a little practice questions. Yeah, so I'll give you about 5 minutes to read through the question. So I think this is one of the past year exam question. So it'd be good if you can, spend some time to read through it and then maybe try to write the use case and then draw a use case diagram at the same time. Yeah, I'll give you until 10:20. Mm. Yeah, I think that's about the time. So I might start with like a couple very simple questions. So first thing, you always need to do when you try to answer the question is, what is the system under discussion? Yes.
Anybody?
Yes, excellent. Okay, second thing, who is the primary actor? Yes. Customer, yes, what else? Do we have one more? Yes. Barista, yes, excellent. So yes, that's excellent. So once you've got the system under discussion and then you've got the primary actors, basically your diagram is all set because you will be able to draw a very big box and then just write the the system name on the very top. And then on the left hand side, you've got your little human figure ready. That's your customer and your baristas. Okay. And then next thing, what features, like what use case are we seeing in this question? Anyone? I think I've highlighted for you. Yes.
Placing an order.
Placing an order, that's a good one. So that's a big one, placing order. What else?
Customized coffee.
Customized coffee, excellent. What else?
Handle payment.
Handle payment, that's good one. What else?
Very good order from the barista.
Viewing order, yeah, for barista, yes. Barista, yes. What else? What else?
Will the notification be one as well?
Yes, definitely. That's a good one. We've got a couple more. So basically, I've highlighted everything like in green. That is the features for customer. And then the things that I've highlighted in yellow, that's with the baristas. Okay. So that should be quite straightforward. So yeah, so this will be the process I recommend you to do when you're trying to come up with a use case and use case diagram. So after you identify those things, it should be pretty easy for you to, yes, you have a question.
So is it the system also like mapping here or no?
System.
Yeah.
System itself is not an actor because this is a system under discussion, right? So I can quickly go back so that I don't confuse you. So in this diagram, so in here, that's gonna be your system under discussion. Yes.
For the use case handle payments, what would that connect?
So you will have handle payment here. And then it's gonna probably connect with a supporting actor called payment service system or like bank system, whatever way you want to call it. Yeah. And then perhaps that's gonna be relevant with barista as well, because barista will or staff member, like they will handle the payment like in the system. So it interacts. Yeah. Yeah. Does that make sense? Yeah, but yeah, don't get confused. Like the system, the bin app, it's the system under discussion. So it's not gonna be any of like supporting actor or anything like that. Okay. And then can you think of the supporting actor in this question? Okay, if I ask you to, yes.
Social media.
Social media? Yeah, could be, yeah. And then how about the offstage? Remember the two, yes?
Payment provider.
Payment provider, that's probably gonna be considered as a supporting actor rather than offstage. Because the payment service provider, they directly interact with your system, right? So primary actor and the supporting actor, they directly interact with your system. However, the offstage actor, they don't interact with your system directly. So you need to be aware of that. So remember I've given two examples, yes?
Not sure would Jim be the off stage after the shop, right?
Yeah, could be because he's the the client
Yeah.
of the system. If he himself is not using the software, then yes, yeah, because he's considered to be stakeholder. Yeah. Good one. Perfect. Let's go to the next. Yeah, we're asking you to write a use case with placing an order. I guess that shouldn't be too hard. Can anyone come up with one main success scenario for me? shouldn't be very difficult, right? Placing an order. Any attempt? You could start from like, customers.
So customer places an order and then chooses a payment option, either cash, card or digital wallet. Yeah, that would be, yeah,
One.
yeah.
Good one. So just be aware when you write in the use case, you select one of option. So you will go like customer placing an order, using the mobile app, and choose to customize coffee to be small, no sugar, with milk. So you need to be specific. You pick one scenario. You don't go with like, or he did do that. And then when you go to the handle payment, you'll be like customer selected to pay with card. Okay, so that's gonna be your one main success scenario. So now if I ask you to write, yes.
I have a question. So for the handling payment, do we start from like the ordering stage and then go to the payment, or can we just talk about the payment stage?
I think it will make sense you start from ordering because that's the whole process, right? At least like you do it from midway, you're like customer paid with card. That's only one sentence.
Yeah.
What is there for you to write? Yeah. Okay, so let's say we've selected one main success scenario to be, customer select to pay by card, and it says, then now I'm asking you to, write our, I think it's casual use case. So you add one alternative scenario to this. So what can the alternative scenario be? Anyone? Anyone, please? I see some of my familiar faces in this desk being very quiet. Anyone from this table maybe for me?
An alternative scenario to that one.
Yes.
Maybe if the customer places the payment on the app,
Yeah.
but their card declines,
Yes.
then like the external provider might say to the system, don't confirm the order, it doesn't go through, and the customer gets notified your card is declined.
Yeah, that's a good one. Excellent. Well done. So just on top of that, I'll probably go with customers card get declined due to insufficient, amount or balance. And then system pop up with our notification be like, you want to select another payment method. So remember, it's important to also show how system reacts when the scenario fails. So it needs to come up with something. You don't just stop like there's insufficient funds and then that's it. That's no good. You need to show how system responds. Yeah. Cool. Excellent. I think that's it for me. Yeah, so this is the answer we given for this main success scenario. Because we've used like a fully dressed style, so you're not expected to write that much. So usually for your use case description, like between 1 to like maximum 10 steps. If you have more than that, that's a bit concerning, okay? Because usually with the brief and casual, it should be like simple and straightforward. You're not expected to write an essay. So try to avoid that. Yeah. Yeah, and also it's also important that you don't skip steps for placing an order, because it will involve like select the coffee and then customize drink, and then also don't forget you also need to have the option of have it here or take away. So these things like you can't skip those things. So remember, like the use case you are writing needs to be like a full process. Okay. That's it. And then alternative scenario that's been given and discussed. So do we also wanted to draw the use case diagram together, or we are confident? I think they should be. Yeah. What do you think? It's just we can't use the whiteboard and I need to open draw.io. So I'm not sure if we want to have this diagram together or. Huh?
Yeah. Yeah.
What does yes mean?
Oh, yeah.
Might as well practice on the diagram. Okay, if you want to draw it on your maybe back paper, then I can maybe have a look. Okay, let me open my draw.io then. Anyone wants to come up and practice? No? Okay. Okay, I might share. Okay. Yes. Okay. Oh, hold on a sec. Is it?
Oh, usually my cable's not popping up.
Yeah. Yeah, suddenly just yeah. I'm just a bit concerning, like I'm trying to share like this, but it's not showing there, so I'm confused. Should I
Oh,
end
sure.
show?
Oh,
Is
I think
that right?
sharing possibly. But are you trying to share your draw IO as well?
Ah, I
Oh,
see it.
that should-
Ah, okay, I see. Okay, perfect. Thank you, thank you. Yes. So as we said, usually we start off with a big box. First thing I will do is write the system under discussion. That's the Bing app. And then here you will have your customer. That's your primary actor. And then second thing I'll come up with is the your second primary actor. That's gonna be barista. How do I spell that? Barista. Okay, that's your second primary actor. And then well, we come up with use case. So remember we highlight that before. So first thing is placing an order. Place an order. Okay. And then what do you think the second one I should write? Second use case, we've got place an order. That's our first one. What's our second one? Customized coffee. Excellent. Customized coffee. That's your second use case. Okay. Or can we have as our third one? I'm just gonna go back to the question.
Choosing an option.
Yes. Choose to have here. Choose,
I'll say like place.
yeah, sorry,
Place.
choose, yeah. Choose place option, yeah. Anything that makes sense is fine. Okay. Yes, what's next one? Handle payment, great. So we have also handle payment. Good. What else do we have? View incoming orders? Yes, great. We have view incoming orders. Yep. What else? Notification, yep. Order notification, yep. Yeah, I think that covers the most. Yeah, option of coffee tragedy replacement. That's also another thing. I'm not gonna draw that because there's quite a few. So now the next thing you do is connect your like your thing with the actor. So who do we connect place an order to? Customer. Okay, it's a bit hopeless. Let me try again. So we have here to here. Okay. So which one do we connect customized coffee to? Customer? Good. Thank you. Yes.
What is extend based on it?
Yeah.
It says the customer name, choose to customize the prompts.
You can. Yeah, that's a good one. Yeah, you can choose to use extends relationship here. Yep. Excellent. Yeah, what else? So which one do we connect these two? Customer, yeah. How about handle payment? I was thinking maybe it should be the customer because it's self-ordering, right? Yeah, so I think it should be customer. So if it's like a register, then it should be the staff member. But in here, it's a mobile app. So yeah. And then which one do we connect the view incoming order? Baristas? Yes, that's good. It's a bit naughty. Okay. How about the order notification? Customer. Yes, good. Yay. That's basically everything for this use case diagram. Any questions regarding this diagram? Yes.
We also have like a payment handler as an impact on the or is it?
Yes, that definitely should be supporting actor. I'm just being a bit lazy not drawing it. Yeah, hold on a second. Let me search for that. Supporting actor. Yes, there we go. So remember the notation for your supporting actor. So for this one, it will be your payment service. And which one should we connect this to? Handle payment, excellent. Yeah, so that yes. Handle payment. Okay, there you go. So this is quite a complete diagram. So yeah, usually I'll say at least come up with one supporting actor. Yeah, and then with offstage, it's up to the question. So if the question says, we want offstage actor, then come up with something. Remember, there's always you can go with the tax agency because no matter what system you design, you need to be aligned with the tax agency and then the government, like, or the stakeholders, depending on the question. Yeah, okay. Should be quite straightforward. And let me continue. I'm just gonna share back to Hold on a sec. Let me stop sharing. Where's my share? Okay, cool. Okay, so that's all about the use case diagram. A quick summary. Textual use case, 3 different styles. You are only required to memorize the brief and casual use case, and then use case diagram. Very simple. Each bubble represents one use case. Active tabs, you have primary, supporting, and offstage. And then with the relationship, you also have the include and extend. Just the mandatory and optional. Quite straightforward. Shouldn't be very difficult. Cool. Next, we will jump into the 5 key diagrams that we've been practicing for the whole semester. So we have problem space and the solution space. So on the left-hand side, we have the problem space. So it's the domain model. And then we are not expecting to see any technical or coding details. Okay. And then, so it can show inheritance, and then show semantic relationships between concepts, but it needs to be unidirectional. And then on the right-hand side, we've got the solution space. It's called design model. Yeah, and then it includes technical or coding details. It strictly maps to source code, defines the formal classes and associations instead of semantic relationship. Note, both domain and design models include static and dynamic modeling. So static modeling is just the class diagram, right? Because there's no actions or anything. And then with the dynamic modeling, it's the sequence diagrams you have. Okay. Cool. Let's start with the domain class. So the purpose of domain class diagram, it shows the key concepts and the relationship in the problem space. So key elements include the classes, the name, and the attribute, and then the labeled associations and the multiplicities. So the only allowed is the inheritance. So with the empty arrow. Okay, we've been practicing this quite a few times, especially students in my class. You probably find this very familiar, but yeah, so we just have to go through this again. So in this domain class diagram, what's wrong with the diagram? Yes.
These errors.
Good one. So we are not expected to see any arrows in the domain class diagram. Anyone? Yes, no visibility modifiers should be there. What else? No message. No message. Excellent. What else? What's wrong? What's wrong? What's wrong? You should be, yes. Thank you. Finally.
I don't think you need types.
Like data types? Yes. Yes. Excellent. What else? We're missing something in this diagram. Yes.
Some of the relationships don't have so only this pays for the transactional algorithm.
Yes, that's a good one. What else is missing?
Finality. The
Multiplicity. Yes, excellent. There's one thing. Yes.
Oh, I mean, it depends if it's like an actual entity, but like transactional log is like software.
Yes, excellent. Oh, here it comes. Now you become my favorite student. Okay. Okay, that's it. Yeah, I think we cover pretty much everything. So no data type should be there. There should be no visibility modifiers. It's missing multiplicity, and then no message should be there, and it's missing some association label. No direct arrow, and then there should be no logger because it's a software concept. Okay, so make sure you're aware of this. Okay, now let's move on to the design class diagram. So the design class diagram shows the software level classes and relationships in the solution space. The key element includes the classes. Now, some with indicators such as abstract or interfaces, and then attributes with visibility and data type. You should see labeled and directed associations when necessary. Multiplicity and dependency. Dependency is optional, of course. And then you also see inheritance and interface as well. Okay. So basically, it's just the things that are not allowed to have in the domain class diagram now pop up in the design class diagram. Cool. Just a little notation revision. So on the left-hand side, you have the private public protector. It should be quite straightforward. You've like learned this in the object-oriented, so it should be quite straightforward. And then you have different lines. So association, that's with solid line. And then you have the inheritance, you should be familiar with that empty triangle. And then you have the implementation or realization with dashed line. So that shouldn't confuse you. With interface, it should be dashed line. With inheritance, it should be solid line. And then lastly, we've got the composition and aggregation lines as well. So that just represents a stronger relationship than the association. Okay, and on the right-hand side, yeah, it's about understanding the association line. So does anyone know, like when you have like the association line like that, what does that mean in the code base? So for example, in this one, we've got student and subject, right? We have like solid line with no directional arrow. Like what does that mean in your code? Yes.
Student might have an array of subjects.
The multiplicity is not specified here, so
They have like this.
yes, excellent, yes. So when you have like a solid line like that, that means they contain each other as an attribute. So should be quite straightforward. And then with the directed association, it means like one contains the other, but not vice versa. But when there's no directional arrow, that means it's both way, right? And then with the multiplicity, if you see 101, it's just one instance. However, if you see like one too many, that means it contains an array list of the other class subject or object. Yeah. Yeah, that should be quite straightforward. Any questions? We all good? Okay, I'm just gonna go ahead with the next one. Yes, now here comes our second little practice. What's wrong with the diagram below? Yes.
I think arrow the wrong way, it should be person pointing towards item.
Yes, excellent. That's a really good one. So usually if you see a line like that, that means item contains a person. But does that relationship make sense to you? Usually you don't expect to see item contain a person, right? So usually it's person owns an item. Okay. Yes. Oh, I'm so really okay. Sorry, missed that. Let's have a look. Hi. Do we need to know dependency relationship? I think we're not very strict on dependency relationship, but if you do draw it, make sure you draw it right. Yeah, but I don't think we're very strict on that. Yeah, so yeah. Hope that answers your question. Yes. Let's continue with this. What's wrong?
No visibility modifier and no data types.
Yes, correct. Excellent. Anyone else? Yes.
No multiplicities.
Yes. Excellent. That's a really good one. What else? What is that little success there? That's probably not a.
It can't have the zero can't.
Yeah, it's more like semantic, but we actually wanted to see the actual data type, like because it needs to be matching with your code base. So I guess it should be seeing a Boolean value here, maybe? Yeah. Cool. Yeah. So missing visibility modifiers and data type, incorrect method return parameter, missing multiplicity and incorrect direction as well. Okay, cool. Let's move on. Now let's move on to the diagram 3. We've got the SSD. That's the system sequence diagram. It captures the interactions between the actors and the system. So in this diagram, you view the system as a black box. And then remember, it is in the problem space, so domain model. So we are not expected to see any software concepts in this diagram. So the key elements include the actors. They can be multi, Usually, but you don't see more than two, usually. And then you have the system, up here, but only one, because we treat the system, as our black box. And then you have those lines in between, that's the message. The lines between the actor and the system needs to be in the correct sequence, okay? So if it's in the wrong order, well, that's probably not very ideal, because in the sequence diagram, we want to know the order of execution. Okay, so it's very important that you draw it in the correct sequence. I think that's it for the system sequence diagram. And then next we have the diagram 4, that's a design sequence diagram. So its purpose is to capture the interaction among the object classes. So inside the system, and it's in the design model. So it's in the solution space. You are expected to see software concepts in this diagram. Key elements including a trigger core, object classes involved in the interactions, method calls between objects shown in the correct execution order. So it's very important for all the sequence diagrams that the things are shown in the correct execution order. And then the life bar. But to be honest, we're not very strict on the life bar as well, because consider the time, sometimes it's not enough time for you to properly draw the life bar as well. So that's it for the design sequence diagram. I think it's very important that you don't confuse between these two diagrams, because the most common mistake we are seeing in the exams or the submissions is that people get confused of the design sequence diagram and the system sequence diagram, where they draw a little human figure for the design sequence diagram, but we actually expected to see a trigger call from this sequence diagram. Okay, so it's very important for you to familiarize yourself with two different types of sequence diagram. Okay, and then another thing is when you have a core like this, that usually means when you have a line drawn towards class 1, that means that method is located in that class. Okay, so that's something very important for you to know. And hopefully if you are given a design class diagram with all the method, that's going to help you to derive this design sequence diagram. Yeah. Cool. Here comes our next little practice. What's wrong with the diagram below? Yes.
Should have a first and third one.
Shouldn't.
Yeah, you should have a first one.
Yes, excellent. Because remember, this is a design sequence diagram. What else? What else? What else? Anything? Yes.
Should have life bars.
Should have life bars, yeah. It'll be better to have life bars, but if you have no time, it's okay as well. We understand that. I don't think we're very strict on that as well. Yeah. I think that's actually pretty much everything. For this diagram. Yes.
Like what?
Yes. That's a good one. So that's first thing. Yes. Excellent. So return variable should be like a dash line. So we actually have two ways of drawing the return. You can either go with option 1, but you draw that as a dash line for returning. And then there's also option 2, where you just draw one line and you can have name equals get name. So both are fine. Personally, I'll go with the second option because I feel like that's more straightforward. And then because you understand, that the design sequence diagram can get very lengthy and then it's gonna look bad. So that's why we want to try to avoid lines where possible. So ideally, if we can draw in option 2, I think that's gonna be nice and simple. Okay. Okay. Now we're gonna practice the same question. So we're gonna practice with the same question. So you should be quite familiar. And then now the task is we draw the domain class diagram together. Yes. remember the little tips we have at the first few workshop, is to, like what you do to draw the domain class diagram is to highlight all the nouns that occur in the question. And then, as long as you cover all those nouns, your domain class diagram, you should be quite safe, like you covered most of things. Okay, we can do this together. I will highlight the nouns. Maybe we can do it together, I guess. We can use, okay, let's pick blue. Called bean body. Okay, let's start with this. Okay, what nouns are we seeing? Jim wants the customer to be able to place an order using the self-service mobile app. What should we highlight? Customer, great. Oh, hold on. Yes. What else? Yes, just give me a moment. Okay. Place an order. Yes, that's a good one. What else? Coffee? Yes. Coffee? What else? How about these? Size, sugar, milk, extra shots?
It'd be like,
Yes. Yes, excellent. So those are nouns as well, and then those can appear. So for the nouns you've highlighted, it's either the conceptual class or the attributes. So sometimes it can be attributes. So nothing wrong with that. And I think it's gonna be a good practice. You highlight also those nouns because that way you don't miss the attributes in your diagram. Yeah. What else? Yes. 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 What else? Payments, yes. Perhaps you want to highlight that as well. The with cash card digital wallet, I guess that could be your attributes. What else? Baristas, great. Okay. What else? Sorry? Incoming order. Because you've highlighted order before already, right? So incoming order is more like I'll say action. Yeah, because it's something highly likely gonna pop up in your dynamic diagram, like the sequence ones, I think. Yeah. Ready. What else? Customer should be, yes. Did someone say so?
like spilling a drink, you can consider that to be like attribute, maybe like orders.
Yeah, you can consider. I'm not gonna highlight that, but yes, you can surely consider as like our an attribute. Yeah. Yeah. Yes. It's something external. Yeah, because you didn't build the social media, right? So I think that's gonna be something external. Yes. Yes, excellent. That's a good one. I think we forget about the feedback feature in the use case diagram, but please remember to add that back in. Yeah. Yes, feedback is definitely one. Perhaps the coffee tragedy replacement, I guess. Yeah, so after this, after the highlight, you should see quite a few classes, in your domain class time. So it's important for you to capture all the conceptual classes because if you miss one classes, let's say if you miss one class, you're missing association, you're missing multiplicity, and you're also missing attributes. So with one conceptual class that you missed, you are gonna lose significant amount. Yeah, so make sure you capture all the conceptual classes. Yes.
But when you're being marked with these like domain class diagram, they're like being compared to like one component. For example, you're like did something different, like I modeled like the classes and attributes that you get like marked down or like.
Extra one or?
Like, I don't know, if it was like slightly different from like the model example. Like, regular like spinning a coffee, you could represent, like, that's like a coffee step, basically. I guess it's own class, but you could represent it as an attribute. Like, exactly.
That is fine, but you definitely don't want to miss like
Yes.
conceptual class, for example, the baristas. Because I think people tend to miss that one, then that way you're gonna miss significant mark because that's one conceptual class. But with the ones you mentioned, I feel like it shouldn't. Not be.
It'd be like a lot of penalty if we miss something, like, let's say, coffee tragedy, so if we didn't.
Don't think I'll consider that as a class, or if it's just an attribute. Like you lose significant mark on missing conceptual classes because that one class can, but interact with a lot of things. All those things are important in some of the next one. Yes. So when classes notify, you read that sentence, that's are actually. That's a bit late, so that's probably not gonna be because domain class level is static. So you don't really need to keep attention. Yes,
Is the feedback here should be a class or an attribute songs?
I would place it as our class. I think it makes more sense because I feel like we have a big yeah. And then if you store it as an attribute in customer, if the same customer leave, let's say 5 feedback, how do you handle that? So that is probably gonna be like a separate class. So you can have some association, like one customer can be many feedback as many as they want. That would be my sense. Yeah. Yay. Okay. We can maybe. Do we still want to draw this together, or maybe I can just show you like a simple diagram we had? Cause I'm just a bit concerning about time. Yeah. So this is the sample solution we have. So in here, I think the customer with feedback. Because you have the order reference, you have the content, you have the barista reference, and then we've got the order. That's good. In here we have notification. I guess that also makes sense. Okay, yeah. So regarding that, because notification is an actual like thing that needs to be sent. I feel like yes, that's actually a really good question. Now the sample solution answer that. And then and then with this one, the coffee charity replacement. I guess this is where the variation comes. So for me, I'll probably just leave it as like an attribute rather than a separate class. But simple solution has like slightly different way of handling that. And then in here they have like inheritance relationship. I think they are probably thinking about the future extension because you don't really expect to see just coffee in the mobile app. So for a coffee store, I guess you also expect it to see juice, other drinks as well. So yeah. But as long as you cover most of the conceptual classes, I think you'll be fine. Cool. Any questions? No? Okay, cool. We are also required to draw a system sequence diagram, but I'm a bit concerning about the time, so I might go through the sample solution with you straight away. So I think it should be quite straightforward as well. So you will start with the customer here, and then you select the desired coffee prompt for customization. and then customize the copy. So remember, we are treating the system as a black box. So you will have Bing Buddy up there. And then after that, it's select delivery options and then enter the payment option. And then the only thing you interact externally is the payment agency. Because you know the system needs to validate the like external payment agency. And then after that, you update the order to the barista. And then there's order confirmation. And then the notification for the order and then pick up enjoy. With this one, it also has a reference notation for the coffee tragedy replacement. We're not gonna go through that. But I think it's gonna be quite similar to the way question is given. So question already write the sequence like for you. So as long as you make sure you cover all the steps in there and then draw it, I think it should be quite easy and straightforward. Any questions for these diagrams?
So we shouldn't really be overly concerned if we don't include like classes, so to be
Yeah.
fun.
There's no line for the system. Yes, so yeah, so I think it's all about you draw the sequence correct. And then to be honest, it's gonna pretty much be very similar to the use case text you written because that is also in the correct order, like you do it step by step, right? Basically, you just converting that to our system sequence diagram. The only thing to remember is you treat the system as a black box. That's all. Next, we also have a design class diagram here. There's a lot more to go through in this one. But I think that one is a bit difficult for us to practice together because there's a lot of content there. You can take a photo of this and maybe, try to go home and then practice this design class diagram at home. Because I feel like to draw with this diagram, we need at least about 15 to 20 minutes. Yeah, so it will be good practice. Do you want a picture of the question as well? I might go back to the question. Maybe you can take photo of the.
Like we can send out the slide.
You are? Oh, okay, cool. Oh, that's good. So as long as you have the question, I would recommend you to do some practice on the diagrams that we don't have the chance to practice on. And then that will be good. Yeah. Yeah, so that's with design class diagram. Okay. Yeah, I think that's it for the first 4 key diagrams. Do we want to go for a 10 minutes break now, or do we want to finish the state machine and then go for a break? Go with state machine? Okay, sure. Okay, cool. Okay, let's go with state machine diagram. So state machine diagram is the very last diagram that we've been practicing. It shows how an object changes state in response to events within the system. So the key elements involves the state start and end and nested state. And then your start state should start with an initial call as well. And then you also have your transition events as well. So in the state machine diagram, you have those circles, that's your state of the object, and then that's gonna change over the time. And then you have those lines with arrows in between, that's the transition lines. And then the text, like the description there is just the event. So something that happens to cause the changes to the state of an object. And then the properties of state machine diagram is the completeness, reachability, deterministic, and well-defined. A couple of common mistakes we are seeing in the state machine diagram first is people always come up with duplicate state. So this is one thing you want to avoid. So for example, if you have an open state, you shouldn't have the second open state, right? So that's one thing you want to avoid. And then second thing is we also see people like with the same description, drawing the line like from A to B and also A to C. So with the same event, like if you have 2 lines, like pointing towards A to B and A to C, you might want to consider that because when this event occurs, like which path should I go? So there should only be one path for you to go through that transition event. You shouldn't be seeing the same transition event allows you to go from A to B and also A to C. That's confusing. Okay, so that's the deterministic. So people should be able to identify event and only go from one state to the other. Shouldn't be multiple ways. Okay. Yeah, that's about the state machine diagram. And then in state machine diagram, you also have the nested state as well. It does not always occur. But if it does, you need to be aware like what it means for you. Okay. Now the next thing is we want to revision on this notation that we have. So remember with the state machine, we have like a notation of trigger, guard, and action. So does anyone know what's the difference between trigger, guard, and action? Or let's change to another question like which one is mandatory in the trigger, guard, and action? Trigger. Excellent. Why? Anyone help? Why do we need to have trigger? Why do we need to have it? Yes.
I guess you need like an initiate action to like one state to another.
Yes, excellent. So you need the trigger to move from one state to another. If nothing's happening, like why is there movement, right? So you need to always to have a trigger. And then for the guard and action, does anyone know like what does that mean? I think maybe somebody writes the pen before. This?
Wait, sorry, ask about the words.
Yeah, trigger, guard, and action, the difference.
Yeah, is guard like basically something that happens when there's conditions,
It's condition.
Yeah.
So guard is the condition.
and then action is just like what kind of describes that transition between.
Action is more like the things happens after that condition is met. Yeah, so it's optional. So guard and action are optional, so it's not always there. So let's take this one as an example. So I think that should help you to understand the question. So in here we have like I think it's about entering the PIN for our card, credit card, I guess. So entering the PIN is the triggering event. So you need to have entering the PIN to trigger the state change, right? And then the condition, which is the guard inside, is PIN correct or PIN incorrect. So that's the different condition. Okay. And then after the slash, there's the action, right? So for PIN correct, it's display the menu. And then if incorrect, it's I don't know what does that mean, but some other action there. And then after that, you are like transited to another state. And then you have two options to draw such a state machine diagram. So you can choose option one, where you just have two separate lines, nice and easy. And then secondly, you also have the selection to use this little diamond notation. So, but if you're using this one, make sure you use it correctly, okay? So the thing is, in here, before the diamond, you will have your triggering event. And then after the diamond, you will have your guard / action, okay? So you need to make sure you understand the notation correctly, okay? I think the most common mistake we're seeing in this notation is that people have 6 different lines connected with this diamond, and then with I don't know 3 different states, and I just get really confused. I don't know which path to follow, and then that's like a really bad sign of using this notation. So ideally, you see about 2, 3 lines, because like for entering PIN, you have PIN correct and incorrect. Then for maybe some other options, you can have like different conditions. But usually you wouldn't be expecting to see like 6 different conditions. Yeah, that's a bad design, I'll say. Yeah. Cool. that's it about the state machine diagram. Any questions regarding this? No? Okay. Okay. So yeah, so with this one, why do I highly recommend you to go to the trigger guard action? And we've seen exam questions that where you are given a design class diagram. So with the methods, and then you are asked to convert that design class diagram to a state machine. So with that one, you wanted to be very familiar with the trigger guard action. Otherwise, you're probably gonna struggle with that type of questions. Okay. Cool. Now, let's do a little practice with this state machine diagram. This should be like, this one shouldn't be very difficult. So we can maybe read the question together. Yeah, I'll do some highlight with you as well. I think when reading through the question, it's important for you to look for specific information. So for this one, the first thing I will identify is what is the object. Yeah, you need to understand what is the object. Then you look for the state of this object. Okay, so these should be the two things you look for to start with. That's gonna help you to come up with like a diagram. So what do you think is the object here? Sorry?
The line.
System is the whole thing, but what is the object in here? Like the state of this object. Not quite. It should be none. It's one object, right? You already have that.
Oh.
You already covered that. None. Yes, correct. So the object in this state machine question is just the pump. Okay. Okay. And then now it's the time to look for the different state. So what state do we have? I think you come up with the one of the state. Yeah. Yes.
Would one of the states just be like monitoring?
Yes, excellent. Yes, monitoring. So monitoring is definitely one of the steps. Actually, I'm gonna use a different color so that I don't confuse you. So the pump is the object we are doing. Oh, yeah. And then what else? Running, getting close, getting very close. Yes. Yes, excellent. So pumping in is one of the state. So pumping water in, and then also pumping water out. Yes.
How do you differentiate that between like action versus like state?
Action and state. I think it's more about you think about the relationship, like you identify the object, and then you think about the relationship between that object. And then another thing is with the actions here. So for example, you read this line, the water level is detected to drop below minimum level. That's like a very long sentence, and that's like an event, right? But But I feel like pumping is more like a state thing, like because for the pumping is one of the states
Yeah.
rather than a transition event. So that's why I think it's really important to come up, like identify the object first, and then I think that's gonna help you to identify whether that's a transition event or like a state. Yes. We have maybe two more state in this question. Yes.
Suspend pumping
Suspend pumping, yes. That's a good one.
and shut down.
Shut down, yes. Well done. So yes, there you go. So you have 1, 2, 3, 4, 5. So you have 5 states in this question. Okay, so this is where I'm gonna start with, like before we draw our state machine diagram. First step, remember, identify the object. Second thing is identify all the states. Okay, then next thing is about looking for transition events. Okay, I'm gonna change to another color here. Okay, we can together do this. So can anyone tell me what's the transition event in this question? Any guesses? Yes, good. So you look for the verb as well. So reach that level and then drop below. So this is the actions, right? Because they start with a verb. So water level is detected to drop below, and then water level reaches minimum level plus lower threshold. And then I guess it's pretty similar for this, rise above maximum level, reach max level minus upper threshold. So that's 4 transition events. So 4 lines already. What else? Overheat, yeah. Overheat and cool down for a few seconds. Yes. What else?
Accident. Okay, we start with
Yes, safe restart signal is received. Well done. I think that's pretty much it. I was thinking if I should highlight update level. That's probably just gonna be a self core. But yeah, I guess that one's a bit optional. But at least I think you should cover everything like below this, right? So these are all your transition lines here. And then so with this diagram, like you can see how many lines you are expected to like come up with, right? So with the state machine diagram, should be quite straightforward now. Do we want to draw this diagram together? Maybe? Yes? No? Yes? Yes? Okay. I'm gonna open a draw.io and then share again. Just gonna stop share here. Yep. Okay. Where are we? Oh, here. Okay. So what's the first thing we do with the state machine diagram?
like a black circle stuff.
Yes, great. Excellent. That's exactly the answer I'm looking for. So you start with our little dot here to indicate that's your start state. And then in this question, wait, it's here. Can you see my screen? You can, right? I'm hoping you can. So what is our start state?
Just
Monitoring, yes. Great. Cool, cool. That's a really good one. Yeah. Okay. So we have monitoring. Okay, there we go. So you will have this as your start state, monitoring. Now, what state do we have? What else do we have? Pumping, pump out, good. Okay, so we have pumping in, we will have pumping out. Ooh. Pumping out, that's good. What else do we have? Remember, we have two more states, right? Suspend. Suspend. Pumping. Yeah, what else? Shut down. Great. Well done, well done. Now, the same thing as your domain class diagram. If you miss one state, well, you lose your mark. Yeah, significantly, because that means you're missing quite a few transition lines. Yeah. Okay. Okay, now. Okay, cool. How do we go from monitoring to I'm just gonna change it to that way, so it's yeah. So how do we go from monitoring to pumping in?
What level below mid level?
Yes. So go to pumping in, you go level drops below the minimum level, right?
Would that be like a guard action? No?
I feel like that's gonna be a trigger. Because there's no another option for you here, right?
Okay.
Yeah, does that make sense? Yeah. So, and then also in here, with this one, it's a level bigger than maximum level, right? Are you able to see it or it's too small? Probably a little bit small, like that, right? So there's also certain conditions to go backwards as well. I'm just gonna do it that way. Okay. Yeah. Oh, should be other way around. Yeah, so what's the condition for going back?
Level above mid level plus lower level.
Yes. Level equals minimum level plus lowest threshold. Threshold. Yeah. So once again, that's your trigger, guard, or action. Trigger. Trigger. Yes, great. So in this question, I feel like there's not much guard or action in this particular one, but in the exam, you may be like expected to see some more. So I can take a very simple example. Okay, actually I can't come up with that. Okay, yeah, so I think that's how you draw the state machine diagram. We are running a bit tight on the time, so I might just stop the practicing here because I think you already knows how to, come up with this diagram. And I'm just gonna go back to the and let me share again. Yeah, right here. So this is our state machine diagram. I'm just gonna show you the sample answer I come up with. But I only take about 5 minutes to come up with this diagram. So if there's some minor mistake, please ignore that. Because I don't really have much time. So yeah, but this is the diagram I come up with. In here, I used a nested state because in the question it says for the shutdown, it's at any given time if the gas is detected. So I feel like it will be like easier this way because this indicates that anytime, if gas is detected, we're gonna go straight to the shutdown state. And then anytime if the safe restart signal is received, we go back to these states, right? Yeah, so that's all. So let's do a quick summary for the 5 key diagrams that we have. We have domain versus design class diagram. Like for domain, remember the labeled association, multiplicity allows you to have inheritance lines and no software concepts. And then for the design model, it's labeled and directed associations, multiplicity as well. You have dependency, that's optional. You have the visibility modifiers, you have the data type, methods, and class indicators like abstract or interfaces. And then next you have the system versus design sequence diagram. So for SSD, system sequence diagram, you have the little human figure, that's your actors. And then you have the system as a black box. You should only see one black box unless you also interact with the external systems. And then you see message between the actor and the system. And then next we have a design sequence diagram. You have trigger call, you have object classes, you have method calls as well. Okay. So remember the key difference here is DSD is the triggering call. You have the object classes, you dive into the system. And then very lastly, we have the state machine. You need to know the start, end, and nested states. You need to know the state machine needs to have an initial call. There's also events. You should be familiar with the trigger, guard, and action notation. And then that little diamond notation, the choose thing, if you choose to use that notation. Okay, so I think that's pretty much it for the 5 key diagrams. And then yeah, familiar yourself for all the diagrams notation. There's modules, you know, that's your best resources. Like, you know, in the canvas, you'll be able to find the UML notation reference. And then for each diagram, like, you know, we provided some notation reference for you. Yeah, should be quite straightforward. Yeah, and I probably highly recommend you to spend some time to draw the diagram. Especially if you've been practicing it with draw.io. I'm not sure the format of the exam. It's paper, right? So if it's pen and paper, like, you know, try to do some practice, like, you know, with pen and paper rather than draw.io, because if you've been using draw.io, you're probably gonna find a little bit struggling to draw it like by hand. So I think really good practice will be the workshop questions, because you have like a solution that you can reference to. So that's gonna help you to know that if you draw it correctly. Yeah. And then try to, you know, manage your time wisely. If you stop here, skip to the next question. Don't spend forever and stop there. Okay. So that's for the key diagrams. Do we want a break? Yeah, I know. Are we just gonna skip the break? What do we think?
In the meantime, if anyone wants to
Yeah. Yeah, maybe we'll cut off to 5 minutes. Break. Great.
Like, I'll get this year.
So I get started.
I think this like, yeah. Probably the other thing. I would like to. It's like. Yeah.
Everybody, we're gonna get started now, so please write down the.
Thank you, thank you. I don't mind if you keep eating, just no more chit chat. Okay, because we're a bit tight on time, we only have about 20 minutes left. I'm gonna try my best to go through everything. So part one, design principles. So let's start off with the grasper principles. So we have about 9 grasper principles. It should be quite straightforward. We have creator, information expert, controller, polymorphism, indirection, prefabrication, and then all these 3 in the middle. So let's start with the probably the easiest one, information expert versus creator. So these 2 is about responsibility assignment. So it's about which class should do what. So with information expert, it's about assigning responsibility to the class that holds the most information to perform it. And then with the creator, it's about the assigning object creation responsibility to the class that is most relevant. So in the exam, I think we've seen questions like you are required to discuss why, like, you're assigning responsibility to certain class. So same thing is going to be pretty similar to a project 1 practice. When you talk about the required information, you want to remind yourself to be specific. When you're talking about all the information required, what information are you talking about? So for example, if you think person should be person class should be assigning with the creation responsibility for item, like there's something item that the person holds to take that responsibility, right? So you want to mention the attributes maybe, or the relationship or the multiplicity. So try to make it specific rather than generic, because one class holds all information. That's a very generic statement. It's not showing that you actually understand what's there, or you can find that responsibility. Okay. And then the next thing I want to talk about is the prefabrication and indirection. So one thing I want to mention, because in the project we've been seeing students talking about that they create another class, and then that class is taking the responsibility because they hold all the required information, blah 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 blah. Well, that's actually considered to be prefabrication or indirection rather than information expert and creator, right? Because these 2 principles does not require you to create another class. Okay, so you wanted to be aware of that, and then try to not make false claims. Okay, so next let's talk about prefabrication and indirection. So this 2 is mostly about decoupling. So how can we reduce the direct dependency between classes? Right. And then for prefabrication, it's about create a non-domain class diagram when needed to maintain low coupling and high cohesion. Because when you create a new class, obviously your cohesion is going to improve as well. Because that class is dedicated with like one single responsibility, and the other class is like having reduced responsibility. And then secondly, we have the indirection, which is using an intermediary object to mediate communication and reduce direct dependency. So example is right here. If without indirection, you just have these 2 classes, right? And then with indirection, you will have like intermediate class in between. Yeah. And then with the prefabrication, as we mentioned, you're creating a new class, and then that also need to satisfy that it's a non-domain class. So that should be that class should not appear as a domain conceptual classes. So for example, logger class. Usually you don't see these things like in your domain class diagram, right? So that's a non-domain class. So the prefabrication needs to satisfy these both condition, you are creating a new class, and then that class is a non-domain class. Yeah. So not just creating any new class does not necessarily mean it's pure fabrication. Okay. Cool. Next thing we move to is the low coupling and high cohesion. So that one is about the design quality. So what makes a good design? Lowest coupling or the highest cohesion? So coupling reduce the dependency between classes for flexibility and reuse, where cohesion keep each class focused on a small and related set of responsibility. So can you tell me with this one, is this high cohesion or low coupling? Yeah. Low coupling, yes, excellent. Because we only have one class, right? You're not coupling with any other class, so that's low coupling. And then on the right-hand side, what is that? High cohesion, yes, excellent, because each class is responsible for only one method. So see, you have different ways of dual design. So there's no perfect solution whereas you achieve both lowest coupling and the highest cohesion. That's probably not possible. So this is why you wanted to balance between these two and then being able to understand the trade-off when you select one of the option to go with. Okay. So this is just an example here to show what's the trade-off and the difference. And then next we have the controller and polymorphism. To be honest, these two is just about behavioral control. How should the system control and organize object? So controller receives system events and delegates work to other objects. So something like that. So it's about managing the business logic rather than the UI element. So try not confuse yourself with this. And then with polymorphism, it's quite straightforward. Use a common interface or abstract class. So this is your abstract class, this is your common interface. So you use this to handle variation in behaviors across different object types. So that should be pretty straightforward. You've seen this long time ago. Yeah, so cool. And then very lastly, we have the protect design for changes. So protect variation, protect against change by isolating variability behind stable interface or abstractions. Sometimes it can be done through indirection as well. Sometimes it's both. So, but if you claim that you have applied protected variation, we need to either see polymorphism or indirection. If we're not seeing those, well, that's a no, because you didn't really apply protected variation, right? Yeah, that's all about protected variation. So we can do this quick question. So I think the grasp principle questions sometimes pop up in the multiple choice. So it's important for you to understand the concept of these principles, so you'll be able to do it right. So which pattern promotes high cohesion and low coupling by assigning responsibility for handling a particular set of user input to a single class? Controller, yes, excellent. Well, C and D is probably no. B is creator, it's about creating objects, so probably not very ideal. So that left us with A, controller. Okay, quite straightforward. Okay, next, let's jump into the part 2. That's the gang of 4 patterns. So we have quite a lot patterns in gang of 4 design patterns. We have, and remember, we have 3 different types of design patterns. We have creational, we have structural, we have behavioral questions. And it's important for you to understand the purpose of these design patterns, because you need to quickly come up with the right pattern you want to go with. So let's do a really simple example. This doesn't cover everything, but let's do a really quick practice. If now I'm asking you that we want to assign a responsibility to create a certain object, what patterns you should pick out of this? If we are creating something.
Factory.
Factory, yeah. What else could be relevant? Singleton, excellent. It's really good. And then usually you expect it to see singleton and factory to go together, right? Singleton factory are usually best friends. Yeah. And then what patterns that we learned also could be relevant when creating an object. It's not in here, but anything? Builder, yes, excellent. So we also have the builder pattern. That's the third creational pattern that we learned in this subject. Okay. Okay, another thing is if I am telling you there is some variation point in the question. So there's some variation in the question. What patterns can you think of?
Strategy.
Strategy, that's one thing. Yes, good. What else? So the moment you think about variation, you think about polymorphism. So what patterns also involve polymorphism? Yes. Adapter, yes. Excellent. That's a good one. What else?
Decorator.
Which one?
Use decorator.
Yes. Decorator, yes. Good.
Like template.
Template, yes. Good one. That's not covered, but you learned that in the lecture. Yes. What else? Composite, yes. Good. What else? Okay. That's actually, yeah, pretty much everything that's covered. So anything that's involving abstract class or like interfaces that could be relevant to the variation point or to the polymorphism. So that's up to you for you to identify from the question. But these things should be the things you look for in the question. Okay, you need to have a goal. Cool. Okay, let's start with the revision with the gang of creational pattern. So as we discussed, it's singleton, factory, and builder. So with singleton, it's quite straightforward. You just need to memorize the UML diagram. Very typical. You need to have an instance with an underline because that represents its static, and also the get instance as well. So you need to memorize this diagram. And then, that diagram just make sure there's only one instance of class is created. Yeah. Yeah, so I think it's more about remember their static methods and attributes in the diagram because it's important. These are the things we look for if you're applying the singleton pattern. You also have the factory. I probably won't go too much detail into factory. That should be quite straightforward for you as well. And then very lastly, we have the builder. So with builder, the use case is about complex object that requires step-by-step initialization. So this one, I think you see a bit less in the exam just because it's usually quite complex. Yeah, but you need to at least know about this pattern. For example, if you creating a car, and then a car is usually quite complex object. It can have like, I don't know, more than 100 components. Then it's probably not very ideal to use factory pattern, but instead you can use the builder pattern. So you can create it step by step. Okay. So that's the main difference between the factory and the builder. So factory is more about a simple and straightforward creation, and then builder is about an complex object that you need to create it step by step. And then the next thing we're going to go into is the structural pattern. We have adapter, facade, composite, and decorator. So with the adapter, it's about resolving the incompatible interfaces. The best example will be the Mini Expedia airline that we practiced in the workshop. Highly recommend you to go back and revision on that one. That's a really good example of adapter pattern. Try to draw the diagram and practice on that question to understand the adapter. We also have the facade. Facade is about you have a complex system or subsystem with functions that we want to access, but it's tightly coupled itself. And then, the system could change in the future. Then you need a single access point to that system. So this is when you need a facade. Okay. I won't go into too much detail for the adapter pattern. So it's basically just interfaces with concrete interfaces. Yeah, so the best example, as I mentioned before, it's in the workshop content with the mini Expedia example. And then decorator and composite. I think this is the one I wanted to go through because there's a slight difference in these two diagram. So remember, we usually not particularly paying attention to your composite or aggregation, but this is the two diagrams that we need to see the composition or aggregation because that's the key of these two design patterns. So it's really important for you to be aware of this because if you are applying these two patterns, we need to see that. So with composite pattern, you have like it here. So you have the interface with the concrete implementation, but with the composite, you also have like an array list of these component. And then with the decorate, you also have that. But hey, the only difference here is, can anyone tell me the difference by looking at this diagram? Like, what do you notice? I'll highlight here.
That's like an array of components.
Yes, excellent. Yeah, so composite contains an array list of the component. However, the decorator only contain like a single instance. That's actually the key difference because with the decorator, you're just wrapping the original one. So you only need that base there. One is enough. And then you just wrap on that. However, with the composite, you actually contain an array list of that. Yeah. So, and then with the composite pattern, usually it goes with another pattern. What pattern is that? Strategy, yes, excellent. So usually you will see strategy pattern and composite pattern. They are sometimes best friend as well. Okay, so it's very important for you to remember this key difference. And then always, please draw this aggregation or composition line for me. It's very important. Cool. That's about the composite and decorator. And then very last we have the behavioral, but I probably won't go into too much detail. With the template method and strategy is very straightforward. Template use inheritance, whereas strategy use interfaces. Okay, so that would be the key difference between these two. And then for observer, this one is probably slightly difficult, but same thing, we need to see like, you know, certain things in the diagram as well. So we need to see, so we need to see this abstract observer base, and then we need to see the concrete observer, and then we need to see an array list of this base list there as well. Okay, so there's a website, I think you probably have that link. It's called couldn't remember the name, and then that website contains like all the patterns UML diagrams, and then you can reference that as our as revision, because I think it contains all the use cases and UML diagrams. I think it's called yes, that one. Yeah, I was about to attach it there, but I forget. Yeah, so yeah, that's all about the Gang of 4 design patterns. Because of the time, we can't go through them one by one. But I think the most important thing for your design patterns, you need to understand its use case, understand where to apply it, and what to look for. That's the most important thing. And then you need to know the key diagram difference, especially like decorator and composite. You need to understand like, you know, what's different there. Okay, and then like template and strategy as well. Yeah, so the very last thing we have is the architectural analysis. Same thing, I probably won't spend too much time on this. I will just recommend you to spend some time on going through these two documents yourself. It's covered in your lecture, I think. On the left-hand side, we have the architectural factor table, which records the influence of the architectural factors. And then in this one, you need to understand the functional and non-functional requirement and being able to, you know, come up with this little table analysis. And on your right-hand side, you have the technical memo, where it's a documentation about records alternative solutions and the decision-making process. So we've seen this type of question like come up in your final exam as well. So highly recommend you to spend some time, just to go through this, so at least you know what to write. Yeah. I think that's all about the architectural analysis. Yeah, I think that covers everything for today's revision workshop. And then here is just some exam tips that I hope that could help. These are the things that you have on the left-hand side. You have your diagrams. On your right-hand side, you have your principles, patterns, and architectural analysis. So these should be the things that you prepare yourself for. And then, do you have cheat sheets, Professor?
Yeah.
You are allowed to. Okay, yeah. Then maybe write something about principle and patterns. And then for the, those diagrams, write down the things that you tend to forget there. Yeah. And then if you are drawing by hand, use the pencil and then keep the diagram neat and simple, because that's gonna really help your examiners to understand your diagram. Yeah. And then manage your time wisely. Don't get stuck on one diagram, and you don't need to draw it perfectly as well, because we do understand the time is tight. I think that's all for the exam tips. Yeah, I guess it's for the question QA. Any questions you have? Ready for questions? No questions? You all happy? I'm gonna all get H1. Well, no questions, that means H1, right? Okay, cool. I think that's all from me today, and I wish you good luck on your final exam, and then wish you H1, okay? I think that's it. Do you have anything that?
Nothing else, just that, we do have this room booked from 9 to 5 actually. So if you would like to stay and continue doing your revision here, feel free to use the, lectern as well, if you want to go through any exam questions off of this. We've got all the time, of course, we don't have anywhere else to put it, we're really appreciate it. But thank you both for coming.
Thank you. Just gonna,
Just had
yeah,
a couple of questions.
sure, of
So
course.
in regards to that architecture and design tool, can you use about like what exactly is the difference?